Let's talk about the buzzword of LLM's town, RAG, aka Retrieval Augmented Generation. So what is RAG? To understand RAG, we first need to understand the biggest limitation of large language models, which is that LLMs do not have information about most recent events. It only has information about events from training data collected until a specified time. So if we have LLM which is trained on public data collected till 2020 and we ask it about the current president of the United States, it won't be able to give correct answer. It might end up saying Donald Trump, who is former president of the states. Apart from this limitation, LLMs are generally trained on public data collected from sources like Wikipedia, books, articles scraped from internet, etc. It won't know private information maintained by organizations like medical records, insurance records, bank records, customer guide records, and so on. If you are working in one of those industries and want private LLM that can utilize this internal private data to answer questions, then RAG can help you. By definition, RAG is a technique for retrieving information from external sources to augment the knowledge of LLMs with accurate and up-to-date information. In simplest terms, whenever user sends a query to LLM, the information related to the query is retrieved from external sources and given as context to LLM to generate better answers. So now with this context info, LLM has more knowledge to generate correct responses. So for our previous example, even if LLM is trained till 2020 data, we can give it a context article that mentions current President Joe Biden, and it will be able to generate correct response this time. The term RAG was originally coined by former Meta AI scientist Patrick Lewis and his team in research paper Retrieval Augmented Generation for knowledge-intensive NLP tasks. Since then, it has been widely adopted by AI community. I will include link to the research paper in the description. Please feel free to check it if that interests you. Now you might have an obvious question. Why do we need RAG? Why can't we simply train large language models with the latest data? Well, the reason behind that is cost of training LLMs. It costs lots of money to train LLMs. You need racks of GPU and training runs for a long time. You will need to set up process to collect data as well, which will require expert engineering. Overall, it's a time, energy, and money draining process. That's why currently only big techs like OpenAI, Meta, and Google are training them because they are cash rich. It's still out of reach for small companies and individuals with limited budget. Other than this reason, when LLMs don't know about particular topic, they hallucinate and produce incorrect answer with confidence. And we all know that misinformation leads to Twitter arguments. Alright, so now that you have a basic idea about RAG and why we need it, let's talk about how does it work in practice. Without RAG, LLM takes user input and generates response based on the data it was trained on. On the other hand, with RAG, the user input is first used to retrieve relevant information from the external data sources. This relevant information and user query both are given to LLM. The LLM then uses this new information and the training data to generate better responses. Overall, the RAG process can be divided into 4 steps. The first step is to collect external data sources and create vector store from it. External data can come from multiple sources like knowledge base of articles, databases, APIs, and so on. The data from external sources are first converted to embeddings using embedding language model. Either the whole document or chunks of it are converted to embeddings and stored in a vector data stores. These vector stores are optimized for faster search. The next step is to retrieve relevant documents. For this, user query is first converted to embeddings and matched with vector stores to retrieve relevant documents. For this, cosine similarity metric is commonly used to understand similarity between embeddings. In the third step, we augment the user prompt with the relevant documents retrieved from the previous step. Here, prompt engineering techniques are used to effectively communicate user query to LLM. The augmented prompt then lets LLM generate accurate and up-to-date answer. The next step is to regularly update external data sources. To prevent external data sources from becoming stale, they are regularly updated with the new information, which is cost effective. Their embeddings are generated and updated in vector data stores regularly. One of the benefits of using RAG is that we can include the source of external information in the generated response for verifiability. This helps build user trust. Now that you know how RAG works in practice, the next questions might be what options are available in Python for implementing RAG applications. There are many different solutions available for building RAG applications with options from various cloud providers. But the most common frameworks used by the Python communities are langchain, llamaindex, and Hugging Face. These frameworks are open source and provide more flexibility compared to other options. For maintaining embeddings of external data sources, vector stores like FAISS, pinecone, VV8, Chroma, and Quadrant can be used. Alright, so that was a small introduction to RAG concepts. In upcoming videos, I will be creating tutorials on implementing RAG applications with frameworks like langchain and llamaindex. So stay tuned to Coders Column. If you have come this far in the video, then thank you for watching and see you next time.